This video is covering AP Calculus, both AB and BC sections 5.6 and 5.7. We're going to look at the derivatives and integrals involving inverse trig functions. So we're going to look at a couple of formulas here. The first one is the derivative of arcsine of u over a. The other one is the derivative of arctan of u over a. So the first formula for what we're going to look at here today is this. The derivative of arcsine of u over a is u prime over the square root of a squared minus u squared. The derivative of arctangent of u over a is u prime times a over a squared plus u squared. And of course these formulas come from somewhere, and so we're going to look at these a little bit and work on where they come from, how they work. And I think I'll choose to focus on this top one here, where the derivative of arcsine of u over a, where that comes from. So I'm going to start over here, and I'm going to start off by writing y equals arcsine of u over a. Our goal here is to find dy dx. And so my first step is to take the sine of both sides. The reason why I'm going to do that is to get it into a more familiar form that we can work with. So when I do the sine of both sides, I get sine of y is equal to u over a. Remember, our goal is to find dy dx. So my next step is to differentiate both sides with respect to x. Using implicit differentiation, that's going to give me this. Cosine of y times dy dx is equal to u prime over a. And then, keeping in mind that my goal is to find dy dx, I'm going to divide both sides by cosine of y, and I will get dy dx is equal to u prime over a cosine y. Zoom back out here just to give you kind of an idea of what we've done so far. So, in pretty good shape. I'm trying to get to this, and I can see that I'm not there yet. The top is looking good, obviously, but the denominator not so much. So what we're going to do is we're going to go back up to this relationship up here. Whoops. This relationship right here. And I'm going to build a triangle from that. So let me get this back to how I want it. There we go. We're going to build a little triangle from this. So I've got arcsine, y equals arcsine of u over a. So this triangle is going to look something like this. My angle is called y. And then arcsine is the relationship of opposite over hypotenuse. So this is saying that the opposite side is u and the hypotenuse is a. Now what we're going to do down here, where we're at, what we're going to do down there is we need to find cosine of y. And so, I look at what I've got up here. Cosine is adjacent over hypotenuse, and the problem is I don't know what the adjacent side is. Think for a minute what I could use to help me find the adjacent side. And of course it is the Pythagorean theorem. So if I do the Pythagorean theorem, I find out that this adjacent side ends up being the square root of a squared minus u squared. Now I can just take this and write u prime over a, and then times the cosine of y would just be adjacent which is a squared minus u squared over hypotenuse, which is a. You can see at this point the a's cancel out, and I end up with u prime over the square root of a squared minus u squared. Of course, that matches the formula I mentioned above. So the whole goal here with this, with this exercise is simply to show you where this formula comes from, and that it works and that it's legitimate. And what we're going to do now with both of these formulas, we're going to practice using them on a few examples. Okay, so example number 1. I'm going to zoom in a little bit on example number 1. And we've got d dx, the derivative with respect to x, of arcsine of 2x. So I want to make sure that I'm very clear on what is what, as far as which part goes with which part of our formula. And so if you remember, the derivative of arcsine of u over a equals u prime over the square root of a squared minus u squared. So looking over here, I can see, I think, pretty clearly that my u is 2x. It might not be very obvious what my a is, but if you think of this as just a 2x over 1, hopefully it's pretty clear that your a is just a 1. So knowing that, I think I can handle this derivative. The derivative then of arcsine of 2x is going to be u prime, and u prime, the derivative of 2x, just 2, over the square root of a squared minus u squared. Well, a is just 1, so of course 1 squared is 1 minus u squared. That would be 4x squared. We square both the 2 and the x. Okay, so moving on to number 2. While you're working on this video, strongly encourage you to pause the video. Now that you know the formulas, pause the video, try the examples yourself, and see how you do. And then, of course, you can check the video later and see if you got it right. Okay, so we know the derivative of arctangent of u over a equals u prime times a over a squared plus u squared. That's actually the one that we proved a few minutes ago. So again, it's going to come down to deciding what my u and my u prime and my a would have to be. So u then would be 3x, u prime would be 3, and a would be 5. So knowing that formula, this is pretty simple. It's just to plug it in and make it work. So let's do that. So the derivative of arctangent 3x over 5, u prime is 3, a is 5, all over a squared, which would be 5 squared, or 25, plus u squared, which would just be 3x squared, also known as 9x squared. Of course, we could write the top as a 15. Obviously, that's the same thing. All right, we'll finish up our examples here in just a second. Okay, so 2 more examples here. Number 3 is our first one, the derivative of arcsine of root x. Using the formulas we've been working on, here's what it would look like. My u would be, I could write it as perhaps x to the 1/2. Therefore, my u prime would be 1/2 x to the negative 1/2. And then my a value would be 1. So using those pieces of information as well as the formula we looked at earlier, the derivative of arcsine of root x would be this. The top is u prime, so that would be 1/2 x to the negative 1/2 over the square root of a squared minus u squared. So that would be x to the 1/2 squared. There certainly is a lot we could do with this as far as simplifying. I'll do at least some of it. Say the top would end up being a 1. This 2 right here, that's kind of disappearing, that 2 would flip down to the bottom, and then the x to the 1/2, or the x to the negative 1/2 would also flip down to the bottom, so it would be x to the 1/2. And then I would rewrite my radical as 1 minus x, since the square root of x would cancel with the squared. Okay, then our final example, again, just encourage you to pause the video, try and do these on your own, and then replay the video to see how you did. So here we go. Using the formula we learned earlier, we need to know what the u is. In this case, the u is x. I also need to know u prime. U prime would then be 1. And then our a value is 7. So, using the formula from earlier and that information, the derivative of arctangent of x over 7 is u prime, which is 1, u prime, which is 1, times a, which is 7, over a squared, which would be 7 squared, or 49, plus u squared, which would be x squared, for a final answer of 7 over 49 plus x squared. Okay, I'm going to go ahead and stop this video right now, and I'll make a second video for section 5.7.